is a developer advocate at LlamaIndex. So he's specializing in retrieval-augmented generation. He's also having a strong background in implementing several research papers, especially in RAG and agents. He has been integrating latest LLMs and embeddings and assisting companies in building efficient RAG pipelines. And I'm sure you are all going to have an interactive session ahead with Ravi Theja, sir. Sir, over to you.
Yeah, thank you.
Thank you, sir.
Is my screen visible?
Yes, review.
Yeah, I think it's visible, right?
Yes, visible.
Yes. Okay. Yeah, thank you, first of all, everyone, for giving me opportunity to present about my work, Navarasa, which is extending Gemma to 15 Indic languages. So let me start a small introduction about myself as well to what someone has added. I work as developer advocate engineer at LlamaIndex, where I mostly work on RAG and agents. I implement research papers, do some research and write some interesting blog posts, as well as assist some companies to build effective RAG solutions as well. Apart from this, in past I worked as senior MLE at Glance. That was a typo. At Glance, where I worked on building recommended systems and generative AI applications. And then I published some research papers as well at ACL and COLING conferences, workshop conferences. And the work Navarasa we have done as part of an open source initiative, like how OdiaGenAI was at Telugu LLM Labs with Ramsri. We both collaborated and worked on building some fine-tuning Indic LLM stuff. So we'll start with the work. So why Indic open source models? The initial motivation was, so whatever models are available, like OpenAI, Anthropic, Cohere, these are mostly on Western languages. That training data itself is very rich in Western languages. But for Indian languages, the tokenizer is not efficient. And even though for some of the models, some basic tokenizers were there, it is slow and 10 to 20x times costly. And also these models are not so great in Telugu language or else other regional languages for local context, as someone earlier has presented for Odia language as well, for Telugu language as well. There are no specific models, and so we thought we'll take a punch on it. And continuing on by open source models. So this gives a ability to run locally, something like you can make these models very efficient and then make local people use on their mobile phones in future as well. And as we build open source, we'll be knowing more business use cases and then see how can we improve models specifically for those specific use cases. And then accordingly make much more smaller models and make it so good that it will be deployable on a mobile itself in future. So the end goal is to train a model that can answer at Quora level question answer quality. Like if you have seen any regional language Quora website, the answers are so granular and so rich. Like if you read in a local language, it feels as if an expert in Telugu has written those answers, and it feels very good to read those answers as well. And then building in open source space gives you a lot of learning opportunity in experimenting with all latest quota techniques as well. So this is another opportunity in building open source. So to start with the training procedure, we started with Llama 2 model, and then we have some initial training steps as well. So for a naive person, like it's like I have a model LLM wherein I have vast amount of knowledge. It's something like I am in 12th grade. I know common learning, and I want to do some specific area. I want to have specific area expertise, right? Like let's say hotel management. What I'll do is I do some 3 years of hotel management degree, and get understand hotel management stuff. So this is called supervised fine tuning. So you take an LLM and for a given task or language, you do some specific training and you get expertise. You make the LLM expertise in that specific domain or language or whatever it is. And then getting degree is not sufficient, right? In hotel management degree, you do a lot of things, but then in real world job, it is altogether different. So then you need an alignment, like training for your first job at Taj Hotels. Like you need again a training of 3 months. First 3 months are very crucial to understand how a hotel works, and then how your team works, and how to respond for different kind of questions to with the customers and various other stuff, right? So this is called alignment. So you should make your LLM to align in a very not in very harmful way, right? So if you ask it how to make some bomb or how to kill someone, it shouldn't respond, right? So that how to kill someone or how to kill make a bomb, right? So that's where safety and alignment comes into picture. So we started with Telugu language. Where we initially thought we might scrap probably QA sets from Quora, but because of license issues, we thought no, first we'll probably go with the translated data sets. We have explored quite a few translated English data sets where people are translating to Indian language or any other low resource languages. And we thought we'll go with we have looked into those data sets, but when general data sets are translated, most of these data sets, English data sets, like questions will be like translate following sentence to French. Okay. And then something like given a map, write a function of Fibonacci series, or given some mathematical problem, solve it. All these kind of questions like coding problems or maybe translation to some other specific Western languages, it doesn't make sense when you are literally translating the same queries to Indian language, right? So we did use some techniques using Power LLM classification model to filter out these kind of samples from the datasets, like write some prompts and making understand to filter out these set of samples from the training datasets. And finally, once you get a filtered dataset, you translate it into your own language, either using Azure API or maybe Google API based on your requirement. But we went with Azure API. Just for the sake, we have credits on Azure. We have taken for Azure. And then the LLM training is actually complex. With Llama 2, we started with 6 months back almost, right? So first we did like we went with vocab extension, and then so first we did learn whatever language it is, like most of it is English, and we took Llama 2, we extended the language tokenizer to Telugu language, and then after that again do pre-training and then fine tuning. That's what like 4 steps process is there. It's something like you have a knowledge of English subject already, but then you want to additionally understand new language, right? Let's say I have English, I know English and Telugu, but I want to learn Odia, right? First, what I learned the basic fundamental characters of Odia, right? That's where I'll start with. If you really want to learn in-depth about Odia language. And then once I understand the basic parts, I'll keep on improving, like from words, from phrases, and then write sentences, right? So this is layer wise. So the tokenizer is like understanding the language capabilities, and then pre-training is getting an overall knowledge of the language, and then instruction fine-tuning is writing proper sentences, proper responses to your language. So this is a 3 to 4 step process that we followed, right? But then what happened is like we trained Llama 2 for Telugu somewhere around February, and then in March we saw Google has released Gemma 7B and 2B model, and so These models, the Gemma model we saw has the tokenization capabilities are really, really good. We don't have to really extend the tokenizer and do pre-training, right? So if you take Llama 2 and then extend the tokenizer and pre-training, if you want the model to perform really well, you need to have very large pre-training in the specific language you are fine-tuning. So since for an OSS models like building OSS, we are GP poor, and also we don't have such huge data set to train like all big tech companies, right? So when we saw Gemma tokenizer, it was very good. I mean, each sentence is, I mean, basically each word is tokenized into its smallest token. It's not very optimal, but the good thing is all the tokens, whatever tokens they have created, tokenizer created, they have very good embeddings representations in it. So rather than extending the vocabulary with small data, directly use Gemma model to do instruction fine tuning instead. So as said, the cons with token expansion and pre-training method was that you had to fine-tune for each language separately. But Gemma solved it mostly with 256K tokenizer compared to 32K Llama 2 tokenizer. And later Llama 3 has come with 128K tokenizer, but still for Indian languages, for not for all languages, the tokenizer is really good. So still Llama 3 might be better than Llama 2, but it's not on par with Gemma tokenizer for Indian language at least. So what recent techniques enable training or fine tuning on a single consumer GPU? So we have a PIFT, LoRa, DORA, and then QLoRa that someone has pointed, and libraries like Unsloth. When we were the initial training, we started with Axolotl, and then we moved to Hugging Face because we were facing some issues in Axolotl. And then when we started with Gemma, we saw Unsloth, wherein the training time is what they were promising is, and even in experimentation, it reduced it by almost 50%. Like so, the training time will be basically 2 to 3x times. If it was taking 100 hours earlier, 106 or 120 hours, with Unsloth, it was taking around 50 hours or 40 hours. So the time spent to get the results is faster, and also the amount spent on GPUs is also far less. So by using libraries like Unsloth, you can train the models faster, get results, and iterate over them in a faster manner. So yes,
So just one question can I ask?
yeah.
Means what difference do the Unsloth library bring to the original implementation so that the training is faster?
Okay, so they did open source, but they did not reveal the whole techniques. But what Daniel was doing is right CUDA level optimization. So that's what he was doing. I don't know much internal details of how he was doing.
Okay, got it. So like means they are also using the same LoRa, QLoRa,
Yeah, the
PFT techniques.
techniques. Yeah, the techniques will be same. It's
Yeah.
just that it's
Okay, they
like
have done some GPU level optimizations.
yes, exactly. It's like you take a lead code, like the basic O(n) square algorithm will give run out of time, right? Like if you submit on lead code. But if you optimize it to order of n or order of log n, the time will be faster, right? It's the same. The problem and the technique is same, but the way you are implementing underlying is different. You are doing a CUDA level optimizations there, GP
Yeah,
level.
yeah. Got it, got it. Like deep speed and all those things.
Yes, exactly, yes.
Got it. Thanks.
So going with the Gemma tokenizer that we have been discussing. So here, if you can see for Hindi, like Bharat Ek Mahan Desh, right? So if you can see, this is not like each token is, I mean, like Ba is not one token, and then A is not one token, but two letters were combined and made it as a token. So this is an efficient tokenizer compared to making each letter or as one single token. If you see Telugu, like each letter is almost a token. And in Tamil, it's a bit better, but still not so great. And Malayalam, better, but not so great. But in Telugu, at least, it was letter level tokenization has happened. So we initially started with Telugu, whatever Telugu datasets we have, and then we fine-tuned it. But then we fine-tuned it, and then we saw really good capabilities with the Gemma Telugu. Then what we thought is, okay, since it is very good, why don't we extend it to 9 languages, which are very much prominent in India. And then that's when the Navarasa one was released. And then people were really appreciating, and then they want to use, and some wanted some specific languages to include as well. Then we went ahead with the feedback and then included almost 15 languages in the whole data set. So this is not one single effort by us. So it is combination of multiple teams efforts. So for Hindi, we have taken Sarvam AI latest dataset, Samvad dataset. It is a multi-ton conversation dataset, but what we have done is since our other datasets, whatever we have, is a singleton. So we want to make sure this is also a singleton dataset. So we just took the first turn of the whole multi-ton conversation in each sample and made a data set out of it. For Telugu, we have created the dataset, English, whatever English dataset we have translated using Azure OpenAI and did that. And then for Marathi, Urdu, Nepali, Sindh, Konkani, Assamese. So for all these languages, we have an English filtered dataset, right? Like the code samples or other language translation samples have been filtered using some techniques, as said. And then we use Azure API, Azure Translator API to translate it to these languages. And then for other languages like Tamil, Abhinandan has created some datasets, and Kannada, others from Tensonic has created some Malayalam, Vishnu J. Prasad. And for Odia, we have taken OdiaGenAI community, whatever you guys have created. And Gujarati as well, others was created. Punjabi and Bengali, Hydra, Indic LLM, people have created. So in this, like I think Punjabi and Bengali, they have used some LLM, some model from Facebook, which is not very efficient. But we are also on verge of our credits on Azure to use it for more languages. So we went ahead whatever is available, but to make much more efficient, I think we need to have much granular data, better data for each language. And then this is what an instruction fine-tuned model for 15 language. Like here we show it for Telugu language. So the model has different kind of capabilities. Like if you ask in English and it can respond in Telugu, or else if you ask in Telugu and ask it to respond in English, it can respond in English as well. Or if you want it to summarize some text, it can do that. And it can, if you want it to do some RAG stuff with the model, it will be able to do. But then there are limitations as well. Even for translation, for some languages it is not so great. Sometimes it repeats as well. It all depends on we need to include much more data to get much better output. So what are some next experiment that we have? So as said, LoRa is one such techniques where decomposing the trainable parameters into low rank matrices, so that you don't have to train very huge parameters, but very less parameters, but still get similar performance. So DORA is one step further in the similar lines. So it adds additional parameters on the magnitude and direction of vector into these low rank matrices. So low rank LoRa plus these additional vector trainable becomes DORA. And so essentially the final goal is with all these latest techniques, if you are doing without these latest techniques, if you are doing full fine tuning, and with the latest techniques with LoRa, you are doing something both the models should converge, like both the models should have same evaluation metrics, same performance capabilities. That's where these techniques are going forward. There is another technique called representation fine tuning, where you significantly reduce trainable parameters to even lower 50x less than LoRa. So all these different metrics, different methods have end goal of, like, these methods should perform as same as full fine tuning of these models, right? So you can experiment with these different techniques on by creating more data sets and see how well they're able to become better in your language. Other one is, as said, alignment, which is ORPO technique. So this is something like I said, how to kill a person, how to make a bomb. So either you generally do SFT, supervised fine tuning plus DPO or RLHF, or maybe a combination of these is ORPO. So you create a data set of ORPO data set and then translate it into any specific Indian language and fine tune such that you basically combine instruction and alignment procedure. So these two separate tasks will become just one task, and you are getting done with it. And some other experiments that or dataset contributions that you can do is evaluation datasets. So most of these models we have been fine tuning for 3-4 epochs or a number of samples, but then how well the models are doing. I know Microsoft has released some data set and the benchmarking as well. I guess one of the session here is from Sunaina as well. So we need much more better evaluation data sets to understand how the models are behaving, and then how where the model capability should be improved, what kind of data set should be included inside uh, inside the training data set to make it much more generalizable. And then most of these models are trained instruction tuned data sets are for singleton. So you need to train these models for multi-turn conversation capabilities as well, and train for bilingual conversation. Like whatever we have done is for, like, take English and respond in Telugu or Tamil or Odia, whatever it is, or take in input in Odia and output in English, sort of thing. But then probably a person from north wants to come to Tamil Nadu and he doesn't know Tamil. Maybe he wants to interact in Tamil language. So Odia to Tamil or Tamil to Telugu, these kind of bilingual language to language translation or conversation capability should be there. And also, so as you give more data, like more pre-training data, whatever we have done is just instruction fine tuning by creating the data set. Probably create more. So there are studies that if you do more pre-training in your language and then instruction fine tuning, your model capabilities are much better. So you do and do experiments on more pre-training and instruction fine-tuning, and then see how models are performing. That will give a more learning experience, and see how the models are getting better. So how to the next one is how to contribute to it. Like the entire thing is not about modeling or architecture. It's more about really very good data sets, right? Very high quality regional QA data sets. Like I said initially, the aim should be like something like on Quora, whatever language question answers you are seeing, we should be able to reach that level, right? So how can you reach that level? We need to create such data sets rather than just translating whatever data sets are available in let's say English language to Indian language, and then do instruction fine tuning. We need such kind of data sets to make models better in respond in our languages. So doing that with manually with human effort, it's really costly and time consuming. So just to experiment, you can use these models. Anthropic, Sonnet, Opus models are really good in Indian languages. And then GPT-4, the recent model, is also very good in Indian languages. Or Cohere Aria is really good in Hindi language as well. So probably you can create such really good data sets using these models, and then open source, and then do experiment with those data sets, and then make the models much better. That is one way you can take. So that's all I have. If you have any queries or need help, you can reach out to me on Twitter at this handle. Yeah, if you have any questions, yeah, I'll be.
Thank you very much, Mr. Ravi Theja. So, any questions from the audience side?
Yeah, hi. Hi, Rateja. This is Karthik.
Yeah, hi.
So, if you don't mind, like, can you share that deck with us? So, as
Yeah,
a reference.
yes.
Yeah.
I'll.
So, like, so I'm curious to learn like this fine tuning and all. If you don't mind, can you give small briefs about like those techniques, like which one when to use, like. So, if you don't mind, can you take 5 minutes, 5 to 10 minutes?
Yeah. So, which techniques you want?
Yeah. So, nothing but like PEFT, like yeah. So, Clora, Lora, like that. See, I don't know much about these things. Okay. So, just I'm started learning.
Okay. I mean, the best is I think I can share the resources rather than telling just wrapping up in 5 minutes
So,
or so.
yeah, that will be helpful. Yeah.
Yeah. So you can search Lightning AI Sebastian Rachaka. He has been sharing resources on LoRa fine tuning and various other fine tuning procedures as well. So I just share.
So I want to hear from you, like just small hints, like when to use which one, like that. Small
Oh,
hint.
when to use each one, I have already shared. So LoRa, see, LoRa is for, I mean, if you don't have a capability of doing a fully fine tuning and you want to make the model better in less parameters updation, you go with LoRa, right?
Okay.
And then, and Dora and Reft Dora and Reft are like latest techniques, which they say I mean, you're trying much lesser parameters and gives similar performance. And Orpo is a combination of both LoRa and then alignment. So if you want both alignment as well as fine tuning, supervised fine tuning, you go for Orpo. Yeah.
Okay. Thanks, Ratija. So and I have one more question also from my. Don't
Yeah.
mind, okay?
Ah,
So like I'm hearing like a lot of buzz about like behind this LlamaIndex and LangChain only frameworks. Okay, regarding
okay.
GenAI. Okay.
Hmm.
So like, could you suggest some points like when to use which one?
I mean, it's a very bigger discussion, but
Yeah.
LlamaIndex has, I mean, like if you want to build RAG for route user queries to different kind of indices, or you want to break down, create complex queries like over different documents. The user queries is like, what is the revenue growth of Uber and Lyft in 2021? Like you need information of Uber first and else Lyft as well, and then consolidate an answer finally, right? So, and then for multiple documents, how do you build your system? It is something like multi-document agents. And then most of the times your documents has text tables, graphs, and various other things. So just using usual parsing stuff and then building RAG out on top of it might not work. So you need some specific techniques like recursive retrieval and then or proprietary solution like llama parse to make to build an effective RAG solution with it. So these are some advantages that you have with LlamaIndex.
Yeah, so I have a question. I have an important question which can cater to the larger audience here.
Yeah.
Sir, yeah, sir, can you please share like which type of model, I mean, how many parameter model we can fine tune in one GPU and using which type of techniques? Means, can you share your general observation? Means
General
in a single, yeah, in a single
Yeah,
GPU.
so I think most of the models, whatever we have trained, it is on 800 80 GB machine. Okay, so
Okay, 800, how much GB?
80 GB machine. But
80.
yeah, we even experimented with 840 GB machine as well. So whatever we experimented with is with 7 billion parameter model and 2 billion parameter model only. So we did not go for 70 billion parameter model for obvious reasons of GPU core. Yeah,
Okay, so minimum 40 GB GPU is required.
40 GB 800.
Okay, so means like we can't do in 24 GB or something.
I think you can't do 40 GB something is minimum required. You need to calculate them. You can experiment them and then see whether it is working or not, because I did not experiment with the 24 GB machine.
Okay, and sir, means this is with the PFT techniques, LoRa, QLoRa, and
Yes,
all.
yes, yes. Yeah, only with LoRa it will work. Without
Yeah.
LoRa, yeah.
Okay, and like which of these PFT techniques are most suitable for this low resource settings? Means
Yeah, I
when
mean,
we
use
have.
the LoRa technique only, right? There is only one LoRa technique. Or you want to go for QLoRa, you can use quantized LoRa as well. But I don't know how much effective it will be.
Okay, great. Okay, thanks.
Hi Ravi, Soumya here. First of all, thanks a lot for this amazing presentation. That was a great learning. So for our our own learning, before Gemma, before you started experimenting on Gemma, I think you did continued pre-training, I believe, on Llama 2, right?
Mhm.
So did you train your own custom tokenizer for Telugu or
Yes, yes, yeah, yeah. So
and
sentence tokenizer we have trained.
and was it really challenging to train? I mean, just for our own learnings or because we could also.
No, I mean the scripts are already available. Like
Mhm,
the script is taken from Chinese Llama, so the code
mhm,
is available of how to. It's just, I mean, you if you know Hugging Face, like it's just
right.
some hardly 10 lines, less than 10 lines of code where you can train and see how your tokenizer is functioning. So there will be some parameters where you can change, play with, and then see how good your tokenizer is. Yeah, it's
All
not
right.
so challenging. I mean, if you want it to be very effective, very
Yeah.
optimal, you need to come up with, you need to work really, dig deeper and then see how can you make it better.
Could you give us some insights as in did you use BPE or which kind of
Yeah,
organizer?
we experiment with only BP.
Uh,
No reason as such, but
okay.
since the earlier papers have taken
Makes sense.
PP approach, we went ahead with that approach.
Right. And I believe you also used ORPO already, right?
No, we did not use ORPO. I
Uh,
was just saying that these are some experiments you guys can carry out if you are
okay.
going forward.
Mm-hmm. So in the lines of data preparation, especially for preference optimization, because for instruction fine tuning using SFT, we are good to go. But for preference optimization, how did you go about generating the data?
Yeah, that's
Because
what I'm
I
saying.
believe you need rank data, right?
Yeah, so for DPO, we haven't created any data sets. So
Mm-hmm.
there is an opportunity to create data set. Like for DPO, you can take English available data sets and translate the same data sets to Indian languages.
Mm-hmm.
Yeah.
Maybe one last question. So out of the box, does Navarasa already, I mean, did you conduct some experiment to see if it already supports or has learned any cross-link language ability, cross-linguistic ability?
Yeah, it sometimes works, but it's not so. So for some languages, what we experimented is like Telugu, Marathi, and
Mm-hmm.
Marathi, Gujarati Marathi. I think one more language we just experimented, but it was not effective. Sometimes for short sentences, like let's say the instructions are something like 3 to 4 words or 5 words, generally it might work. But if the instruction is very long, let's say 10 words or 20 words, it just goes away.
But then you didn't fine-tune it on this cross-lingual data. It just
Uh,
learned out of the box. Okay.
yeah.
That was yeah, that would be something very interesting to explore, I believe. Yeah, thanks a lot.